Welcome to the next installment of my video lecture series in economics. And in this particular video, I'm looking at section 2.1, text problem 1.6. And this is part two of videos for this particular problem. The other one I started out working through some of the issues with this problem that people were having. So this is a continuation of that previous video. As you remember, Orion had 1,000 workers in its labor force, and the opportunity cost of producing 1 ton of granite was equal to 3 bushels of blueberries. So every time a worker produced 1 ton of granite, that meant that 3 bushels of blueberries was not being produced. So what we can infer from that is if we want to produce the same amount of granite, tons of granite in terms of bushels of blueberries, we would need to have 3 workers producing granite for every 1 worker that is producing blueberries. So what that means is 75% of the workers are going to be producing granite and 25% of the workers are going to be producing blueberries. So what we've done is identified the distribution of workers in order to have the production of tons of granite equal to the bushels of blueberries produced. It's a 3-to-1 ratio, which means that 75% of workers are producing granite and 25% of workers are producing blueberries. So if I take that 75% and multiply it by the 1,000, that means I'm going to have 750 workers producing granite. And from the original table, we know that the typical worker in Orion is producing 4 tons of granite in any month. So if we have 700 workers producing granite at 4 tons of granite per worker, that means that 3,000 tons of granite will be produced. We know that 25% of the labor force is going to be used for blueberry production, so that means 250 workers are going to be utilized, and that the productivity of the typical worker is equal to 12 bushels of blueberries per worker. So I multiply that 250 times the 12, and that gives me 3,000 bushels of blueberries. So you can see here that the amount of tons of granite produced is equal to the amount of bushels of blueberries that is being produced. So make sure you understand that. You use the same exact process when you do it for Scorpius. Hopefully this is helpful to you for this problem. This should also straighten out the rest of the problem because every other calculation, it seems, was based upon getting this calculation correct. So now that you've got this particular calculation correct, you should be able to answer the remaining the remaining parts of this particular problem.